Alrighty. Outline how this diagram, so here are the gravitational field lines coming in, right? And you got to picture this, in 3 dimensions, but that's okay. But why does it say that the gravitational field strength decreases with distance? Well, what's happening to the separation of these field lines? The closer they are together, the stronger the field. So as you go away from the planet, what's happening to the separation of them? By separation, I mean this distance here, right? Right. Out here, it's more, right? So therefore, there's fewer field lines per unit area or volume, right? And therefore, it's decreasing, right? Okay, and then they say that the potential right here is minus 3 v. This guy is just minus v, and then they want us to find the place where it's minus 2v, right? Which is sort of counterintuitive. It's not like we got to figure this out, right? So remember that potentials are minus gm over r, right? And notice that at the surface, we're actually 2 units, whatever these are, right? We're 2 units from the surface, right? So we know that minus gm over 2 is equal to minus 3v. I'm just setting up an expression, right? We're 2 units, whatever these are, these squares. We're 2 squares away, right? Okay, so then there's going to exist some distance, right? So minus gm over x from the center, right? Okay, so gm over x is going to equal minus 2v, right? Well, we don't know what v is, we don't know what g is. Well, we do know what g is, right? We don't know what m is, but we know that these are 2 expressions, right? We got this equals this. We know that this equals this. X is the distance, like that. So just divide this by this by this, right? If you do that, the v's go the way of the bison, the gm's go the way of the bison, and you end up with negative 1 over 2 equals 3 divided by negative 1 over x equals 2. We'll cross multiply and do maths, and you'll figure out what x is. X is going to come out an even number of squares, okay? Yeah? Yeah, good luck. I think you can do it.